Okay, so at this point, we've talked about the formulas of compounds or molecules, and we've talked about how to count the total number of molecules. Now we want to start figuring out how we can look at how is each molecule, what's its percent composition? So for example, if we have a water molecule, what percent hydrogen is it? And what percent oxygen out of the total water molecule? So it's the same thing as looking at a bowl of fruit. If I wanted to look at this bowl of fruit, and I wanted to know out of this bowl of fruit, what is the percent mass of just the bananas? So I want to know how much mass do the bananas contribute to the overall mass of the fruit? Well, to figure that out, the first thing I would do would be to put this entire bowl of fruit on a balance and get the mass of the entire bowl of fruit. Then I would take out just the bananas and I would put them on the balance and I would get the mass of just the bananas. And if I wanted to know the contribution of the bananas to the entire mass of the bowl of fruit, I would take the mass of the bananas and divide it by the mass of the total fruit bowl, and then I would multiply the whole thing by 100. And that would give me the percent composition of that fruit bowl that's due to the bananas. So to get the percent composition of the fruit bowl that's due to bananas, I would take the mass of the bananas and divide it by the total mass of the fruit bowl. Now we're the exact same thing with molecules, right? So let's say I want to know what's the percent composition of hydrogen and oxygen in water. So the first thing I would do is I would assume that I just have 1 mole of the compound, of the molecule. And it doesn't really matter how much you have because percent composition is not going to change. If I have some object and at 50% of its mass, let's say I take, I don't know, people. If I have 50% of their mass is equal to some number, it doesn't matter if I have more. 50% is 50%. It's half. Half the mass will always be due to that particular object. But to make the math easy, we're going to do an assumption that we only have 1 mole of the molecule. So if I have 1 mole of water, I know that its molar mass is 18.02 grams per mole. So 1 mole of water is an equivalent of 18.02 grams. So I also know that in 1 mole of water, I have 2 moles of hydrogen. That's from the chemical formula. And there's 1.008 grams of hydrogen for every mole of hydrogen that I have. So if I do this math, I'm multiply 2 moles of hydrogen times its molar mass. The moles of hydrogen cancel out, and I'm left with the mass of hydrogen, which is 2.016 grams of hydrogen. So that's telling me in this 1 mole of water, I have 2.016 grams of hydrogen. So then if I divide by the 18.02 grams total in 1 mole of water, and then I multiply by 100, that tells me that water is 11.19% hydrogen. So 11.19% of the mass of water is always going to be due to hydrogen atoms. Let's do the same calculation with oxygen. I have 1 mole of oxygen in my 1 mole of water. And we know that 1 mole of oxygen has a mass, a molar mass, of 16 grams. So now my moles of oxygen have canceled out to allow me to calculate the mass of water that I have. That's 16.00 grams. So in that 1 mole of water, where I have 1 mole of oxygen then, I have a total mass of oxygen that's 16 grams. So if I divide that by the total mass of that 1 mole of water, which we've already calculated to be 18.02 grams total mass, and then I multiply by 100, I get that 88.81% of the mass of water is due to oxygen atoms. So that means no matter how much water I have weighed out on the balance, of that mass of water that I have, 11.19% of that mass is due to the hydrogen atoms that are present, and 88.81% of that mass is due to the oxygen atoms that are present. And we call this percent mass composition. And it's never going to change no matter how much water you have. The percent mass will always be the same because it's a ratio. Percentages are relative.